In the
सर
Pioneer, हाँ.
स्क्रीन शो नहीं हो रही सर, ब्लैक ब्लैक शो हो रहा है.
Okay, let me share again. Now is it visible?
नो सर.
Anyone else with the same problem? Is the screen visible to you people?
Yes, sir.
सर नेटवर्क प्रॉब्लम मिलेगी सर.
Might be window, it might be at your side.
हाँ सर, नेटवर्क प्रॉब्लम मिलेगी सर.
Okay, okay. You can see in the recording.
ओके सर.
Okay. Okay, so yesterday we people discussed about the Pioneer-Cartan integral invariant. Now today we are just replacing the roles of T and Q1. Means in place of T we are considering Q1. So assume the Hamiltonian function H, which is a function of T, Q1, Q2, Qn, P1, P2, Pn. Its negative is denoted by Z, as in equation 27. Now, from this relation, we can solve any of the coefficient in terms of the other coefficients. Like we can solve Pi in terms of T, Q1, Q2, Qn, and then on the right hand side, Z will be involved, and after that P1, P2, Pi minus 1, and then Pi plus 1 and Pn. So any variable can be expressed in terms of the remaining variables and the function Z. Assume that very new expression is denoted by minus k. If it is so, then the Pioneer-Cartan, which was summation I from 1 to n Pi del Qi minus h delta t. Now, in place of minus h, we are having Z. So it is Z delta t plus P2 delta Q2 plus P3 delta Q3 and so on. And now P1 is replaced by minus K. So it is minus K delta Q1. And now if we are comparing equation number 29 with equation number 24. Okay, I'm trying something so that we can see all the equations on one page, but it's not possible. In equation number 24, we are having P1 del Q1, P2 del Q2, Pn del Qn minus h delta t. However, in equation number 29, we people are having Z delta t plus P2 del Q2, Pn del Qn minus k delta Q1. So, in place of h, we are having k. In place of t, we are having Q1. In place of P1, we are having Z. And in place of Q1, we are having t. So, the Hamilton canonical equations will be, Hamilton canonical equation was dqj by dt, but in place of t we are having q1. So in equation number 31 you can see dqj by dq1 instead of t we are having q1 will be equal to in Hamilton canonical it was curly h by curly pj, but here instead of k h we are having k, so it will be curly k by curly pj, and then dpj by dq1 is equal to minus curly k by curly qj. So in Hamilton canonical equation, t is replaced by q1 and h is replaced by k. And equation number 31, because in 31 the variable j varies from 2 to n. So total 2n minus 2 equations are covered. But we need to cover all the 2n equations. So 2 are remaining. Those two were dt by dq1 is equal to curly k by curly z. Why it is so? Because in Hamilton canonical equation, the first equation was dq1 by dt is equal to curly h by curly p1. But now h is replaced by k, p1 is replaced by z, q1 is replaced by t, and t is replaced by q1. So, replacing all the roles, we obtained this equation. And the second one is dz by dq1 is equal to minus curly k by curly t. So, we have just interchanged the roles of the variables. And now these equations are obtained, that is 30 and 31. Again, one example is discussed in this concern, in which, sorry, h is given like p square by 2m plus cq square by 2. Then z is minus h, so z is equal to minus p square by 2m plus cq square by 2. From here we can evaluate the value of p, and that value will be p is equal to under root m under root of minus 2z plus cq square. Thus k, which is minus p, it will be minus under root m upon under root minus 2z plus cq square. And thus dt by dq, it will be using the Hamilton canonical equation. Yes, dt by dq will be curly k by curly z. Okay, so dt by dq will be equal to curly k by curly z. So we have find out the partial derivative of k as shown in equation number 4 with respect to z. So equation number 5 is obtained. And dz by dq, it will be 0 using again the equation number 30. So from here z is a constant, say it is h. Replace z with h in equation number 5. We obtained one equation for t and q. That equation is solved and the values are obtained using some basic integration methods. So wt plus d will be equal to sine inverse under root of cq by 2h, where w will be under root c by m, and hence the value of q is obtained, and so a is defined. So this is the solution of the canonical equations. Now let's try the Whittaker equations. To obtain the Whittaker equations, just a second. Yes, consider a generalized conservative system for which the Hamilton action is not explicitly dependent on time. Means h is a function of qi and pi only. Or we can say curly h by curly t is 0. But we know the Hamilton canonical equations are dqi by dt is equal to curly h by curly pi, and dpi by dt is equal to minus curly h by curly qi. Now the total derivative of h with respect to t, it will be using the chain rule, summation I from 1 to n, curly h by curly pi qi dqi by dt, and plus curly h by curly pi dpi by dt. Now replacing the values of dqi by dt and dpi by dt from equation number 3, we obtain the next line, and in the next line there are two terms which are negative of each other, so it will be 0. It means the derivative of h with respect to t is 0. So h is a constant function, and hence h qi pi is a constant function, say it is h. Now what happened? We assumed that h is not explicitly dependent on t. And due to that, it happened that h is a constant function. Now, okay. In these lines, it is assumed that the partial derivative of h with respect to qi's are 0. Then the qi means h is not a function which depends on qi. It means qi will be a ignorable or cyclic coordinate. So if we are having some ignorable coordinates, we will ignore those, and there is no need to consider them. Thus, to work, we are just assuming that h depends on all the coordinates, and so we are going to work in the 2n dimensional phase plane. And in this plane, we just collected all those points where h will have a constant value, say h naught. So h, which is having the value qi naught pi at p, qi naught pi naught means initially to be equal to h naught. Now what happens? The Poincare-Cartan integral invariant, it will be integral over the curve and will be equal to summation I from 1 to n pi del qi minus h delta t. But t is not explicitly present, so variation of t is 0. So we will have summation I from 1 to n pi delta qi. Now we are assuming p1 is equal to minus k as stated in the remark. So h can be written like summation j from 2 to n pj delta qj minus h delta q1. And now comparing this equation number 9 with the generalized Poincare-Cartan integral invariant, we obtained that h is replaced by k, p is replaced by q1, and the values are moving from 2 to n. So the Hamilton canonical equations corresponding to equation number 9 will be dqj by dt, but t is replaced by q1, so it is dqj by dq1 is equal to curly k by curly pj, because h is replaced by k. Similarly, dpj by dq1 is equal to minus curly k by curly qj. Okay, so the equations obtained in 10 are known as Whittaker equations. Okay, I am leaving it today. Tomorrow we will derive the Jacobi equations.